Hello everyone, my name is Awa. I'm one of the co-founders of Anoma. And today I'm just going to give you an introduction about this. So I would like to start by thinking a little bit about the history of how protocols, decentralized protocols have evolved. And I like to think of the very first generation as it introduced the idea of scriptable settlement. It was pioneered, of course, by Bitcoin. And as you know, scriptable settlement is really good for building certain applications, particularly cryptocurrencies or different alternative monetary policies. But what not so many people remember is that actually when scriptable settlement came along, you could also build all kinds of interesting applications using Bitcoin script, for example. And some of those are like color coins, name coin. Does anyone remember any of these applications? Could you raise your hands? Wow. Okay. Color coin, name coin. Does anyone remember there was a Bitcoin stock exchange? Wow. Okay. One person remembers that? Not even. Okay. Wow. Okay. So there's a lot of actually applications to build with this. And then predominantly what was really good at it was for cryptocurrencies. So then Vitaly came and he actually talks about this in the white paper. He said that scriptable settlement is actually good enough, expressive enough to use some applications like name coin, color coins. But in the end, it always came up a little clunky because it wasn't expressive enough for that. So he came and proposed a radically different architecture, which was programmable settlement, adding a lot more specificity at the settlement layer. And with Ethereum, you could actually build better versions of what color coin was, currently known as ERC20s, or endpoint, currently known as DNS, that more widely established. DAOs, a bunch of other cool applications like NFTs, SBTs, and so on. And there are actually more applications than different kinds of tokens and DAOs. There are a lot of very interesting, very interactive multi-party applications like Uniswap, 0x, Bitcoin, HouseSwap, OpenSea, Wyvern, Starknet, Layer 2s. And all these working applications do work currently with Ethereum, but it does cover the programmatic settlement part. But it has basically two main trade-offs. The very first one is that these application protocols are actually application specific, and that at least one part of their stack in the design is decentralized components, a trusted component. So ever since then, ever since Ethereum came, which is by now more than 7 years, there have been many advances in civil resistance, in scaling, in privacy, in consensus. But I kind of like to think about all of them as second generation programmable settlement plus, because in general, if you look at them and then how the application paradigm and logic is, it's still programmable settlement. So the conclusion is that settlement is actually not sufficient. It is sufficient when you already know which parties you want to settle with and what it is that each of them wants. But as you can see with many interesting applications that are modern, there are actually many. The main thing is that you need counterparty discovery, and you need to wait for this counterparty. So after discovering each other, you need to wait for them to agree on what to settle on. And the examples for those are marketplaces, product discovery mechanisms, DAOs, and roll-ups. There are some approaches to counterparty discovery. One way of doing it is to do it on the blockchain, on Ethereum, for example. The best application that shows this way of doing it are AMMs like Uniswap, or on-chain oracles. This works, but it's kind of actually really expensive. There's no need for that to be fully ordered on-chain. And it's a little bit, it's probably not like the most elegant way of doing so. You can go for the most commonly adopted approach in architectures, which is you have one part of the stack that is basically a single operator database. This is how OpenSea does it with 0x relayer, flashbots relayer, sequencers, and so on and so on and so on. But the issue here is that they become decentralized at the point. You can also do another approach, which is basically deploy an app-specific for sovereign chain like DYDX. But it does come with trade-offs, and it does add a lot of complexity to the developers and application users. Because DYDX now has to worry about the token, and the developers have to worry about not only about the logic of the DEX, but also the logic of the entire chain and consensus. So what we're proposing here is actually third generation. How about we basically provide a full stack architecture that allows you to build some of the modern applications and even some novel applications with one architecture, and which is one unified architecture. And this is what Anoma is. So in a few sentences, and you need to grab this, Anoma is an intent-centric, privacy-preserving protocol for decentralized counterparty discovery, solving, and atomic blockchain settlement. And today I will only focus on intent-centric, and we'll also talk a little briefly about some of the privacy-preserving parts of the protocol. So there are two design principles that are that Anoma is centered around. The first one is that it is intent-centric. The second one is regime architecture and then regime security. So intent centricity. First of all, users have intents. Users do not reason through transactions. Users do not reason through like smart contract call stacks, and they don't think like that. When users decide to interact with the protocol or with the application, they have an intent, which is basically an expression of their desired state transition. The users want to express, and with the intent-centric architecture, what you can get is that users can actually express what they want, the desired state transition, and not how they get it. Intents are binding, they are signed messages, and they are they're basically programmatic commitments. And the way we do this is, I will actually show you later the diagram of the architecture. It has this component, but this is actually necessary to enable decentralized counterparty discovery. And an interesting take from this is that it leads to a change. It changes the way we have to think about applications. It leads to a more declarative paradigm. And this is what declarative means. As in, here, the ideal way for users to interact with Anoma would be that the user only has to worry about specifying the intent, besides the state transition. And just this intent gets handled by Anoma. And in the end, the only thing they need to check is whether it was settled or not. So I won't go through everything, but basically these are the main parts of the architecture for Anoma. And the first part on the far left is the counterparty discovery side. So it has 4 blocks. The user of the client can custom them to the solvers. It is intent-centric, so intents can be anything. And here we're handling the 3 kinds of intents. So the first intent is where it's just transparent, like public functions. This intent is created by the user, and then the intent is just sent around, gossip around, but you can possibly it's feeling that is not necessarily it can be sparse, as in the there may not be an overview of all intents. And then there are these agents, like we call them solvers, and solvers are incentivized to just monitor the existing set of intents and try to find the ones that directly or indirectly in conjunction satisfy each other. Solvers are the ones that actually create the individual transaction, which later on is put against value, it goes to consensus. And another particularity about this declarative paradigm is that we have another thing, which is validity predicates. Validity predicates are just designed for smart contracts, or it differs in the way the execution flow. Instead of just step-by-step execution, the way validity predicates work is that at this step, before validators actually apply to finalize the state changes, all the involved validity predicates get called and get verified, and only if they all pass, then the state actually gets finalized. And in the end, the user only needs to verify when they settle or not. So here we have actually a unified execution environment, and this is important when you want to play with when you want to build applications that might simultaneously require some transparent state, shielded state, or privacy. So the difference between transparent intent and shielded intent is that a shielded intent can carry a proof that is fully private, but the what of the intent is to keep it transparent. So it carries the proof of the proof. And then everything else is the same, except that in the unified execution environment, they will be verified per second. And this is actually as private as you can get if you want to retain your activity, if you want this kind of product discovering, and you want to rely on those knowledge proofs. But what would be really cool is that you can get to a state where the entire intent is fully encrypted, fully private, and not even the who is actually known as transparent. But for that, we'll actually rely on fully homomorphic encryption. And yeah, we'll have to see. So the idea around homogeneous architecture and heterogeneous security is that protocols can be benevolent monopolies. Just think about a lot of the real world infrastructure, like the cellular, like the internet and everything. Everything has one standardized architecture, but then really it is your choice about which security domain it is that you trust. And there are multiple benefits, such as like security domains are like being giving the user the choice to trust the different security domains avoids these issues around like having to trust security domains on local, registration, and a bunch of things. So Anoma's architecture, and you can actually deploy it with different ways. You can deploy it as a layer 1 server chain. Let's say basically the same architecture, but you might customize who build and who operates it in the security model. You can also deploy it as a layer 1 compound, as imagine that there is an existing application in Ethereum that wants to centralize the sequencer, wants to centralize part of their stack. Then they could basically use the kind of product discovery and solving part of Anoma, but still decide to settle on Ethereum because for some reason they want to keep the endpoint on Ethereum. Or you can also just use it as a layer 2. You can build apps here while keeping settlement. Some applications they can build on Anoma. Basically, everything that is around decentralized exchanges right now, you get from the get-go with the basic architecture. So for fungible tokens, the fungible tokens with Furnace and with your protection guarantees, rollups, optimistic labs, and ZK labs. Product funding, the Bitcoin's really good project if you don't know it. But there are also some novel applications that you can build. For example, private DAOs, where some parts of the state are not transparent, but some others can be private. Private auctions, games, and like this is the part about basically here you can let the user define what kind of text they want to be operating on, as in because the intent is programmatic and you can express whatever it is that you want to train in there. Basically, you can, even if there wasn't a text for this particular set of NFTs, collections of NFTs, you just create yourself. And a bunch of cool stuff like fundamental rules. So, just a bit of overview of cryptography on Anoma. This is not just a bunch of proofs. I just noticed it, but I think you should just check it out later on GitHub. Our specs are open source as well as so Namada is the first crypto instance. There's a few projects that I might find very interesting, like NSP, Vermeer, Vampire, and Taiga, and then our research and search. So Anoma is built by Felix, and these are my two co-founders. Adrian is still around, Christopher is not much strong, but I also have a few team members running around, so feel free to just chat with us. So Anoma is a unified architecture for perspective visualization, and that's it. If you have any questions, let's see them.
From the audience. Does anyone have any questions for us?
Oh, I forgot to say, we actually have printed copies, hard copies of the draft white paper. There are some limited copies over there. It might be pretty interesting for you to have a look at.
Any questions for Awa?
So when you actually said that this atomic cross-chain settlement, am I not audible? You said that you provide atomic cross-chain settlement.
Oh, yeah.
Yeah. So if you don't mind, can you just briefly explain what that is?
Yeah. Okay, so this is referring to that. Well, I have to go all the way back. So atomic multi-chip settlement. The idea here is this architecture is in 10th century, right? Like in the ideal world, if a user defines an intent that involves the let's swap two assets that at the moment living in two different chains with different security domains, what you want to do is enable that intent to be settled without having to use atomicity. So right now, with all bridges and interoperability protocols, it requires that you can use atomicity because you have to move those assets to one security domain in order to enable that intent to be settled, right? But ideally, you want that to be stay in the initial security domains and still enable the swap with the next security domains. That's what I mean.
Yeah. So does that mean that you're deploying Anoma as a L2 on top of both chains?
No. So in order to enable actual chain atomic settlement, you would need novel consensus. And we are building, we call it Python. You can also check out the repository. It is an implementation of consensus protocol. It's a consensus algorithm called heterogeneous taxos. Yeah. You should take a look at it. I think it's very novel consensus. You can think of it as like the next evolution of DLT.
Yeah. So you still sort of like because I'm not sure how you're operating across security domains. So I think that you sort of have something implementing that consensus of both chains. Okay.
This is just novel consensus algorithm.
Okay.
And in order to achieve this, the other chains will also have to adopt this consensus
Okay.
Yeah.
We have one more minute for any questions.
Thank you for your explanation. I'm just wondering about the performance of Anoma blockchain. So how many transactions can be handled per second?
Could you ask the question again without answering?
Okay. How many transactions can be handled in the Anoma per second?
So the very first version of Anoma is likely running Tendermint plus proof of stake. So I guess throughput you can compare it to basically any BFT chain, any modern BFT chain.
Okay, I think, thank you, Awa, for your presentation.